My best video so far has 10 views, so we're doing right on track. Here we go. We are converting back and forth from polar complex to rectangular complex. This is super easy. All right. These are the two different forms of complex numbers. Yesterday we graphed the top one. Z equals x plus iy. That's what we just talked about a second ago. Something like 3 plus 2i. The 3 is my x value, the 2 is the y value, and then you have an imaginary number. If I were to graph 3 plus 2i, remember what we talked about. This is the real axis. This is the imaginary axis. It's just like graphing x's and y's. You would go right 3. You would go up 2. That is 3 plus 2i. Good. Today we're going to introduce polar complex. Polar complex looks like this. Z is just a letter that often represents imaginary numbers, so that's what we're calling it, or complex numbers. Z equals r cosine theta plus I sine theta. When we set this thing up, we're always going to just be plugging in for r and theta. The cosine, the I sine, the parentheses, everything else stays the same. So this first problem is exactly what we just did in bell work. All we are doing is converting. Yeah, there's i's in it, but it doesn't change anything. So in this first problem, we are converting from polar complex to rectangular. So we've got polar numbers. That means they probably gave us r and theta. And we're going to rectangular. That means I need x and y. That's about it. The only difference is that you have to pull it out from this problem. So when I look at this guy initially, what's my radius going to be? 2. My r is 2. And my angle is 30 degrees. I am changing that to x and y. Do that just like we did in bell work. Converting. If we're going to r and theta, that means I'm using r cosine theta. X equals r cosine theta. And y equals r sine theta. I'm very confident that you can do this, so I'm going to do it quickly. 2 times radical 3 over 2. And this is 2 times a half. Those cancel, it gets you radical 3. Those cancel, it gets you 1. Those are the numbers, radical 3 and 1. That's my x and my y. The only difference between what we did in bell work and what we're doing here is how we write our final answer. These are complex numbers. All right, so it's a little bit different. We are going to write this as z equals x plus yi. So it's just 1 times I or just I. This number right here is the same as that number right there. It's just converted. Kind of makes sense on what we did there. It's just conversions. Don't let it be weird to you. All right, if you don't believe me, let's think about a graph. So if I wanted to graph this new answer, okay, I've got a real number line and then the imaginary part. The real part is the radical 3, and so it's going to take me on the x-axis to radical 3, which is a little bit less than 2. What's my y value going to be? My y value is 1, and so I'm like right in that spot. That's that answer. If I were to graph the original number, 2 cosine 30, or 2 and 30, so I would go to the second radius, and my angle is 30 degrees, so I'd be on this line right here. 30 degrees would be something like that. Notice how those 2 points reference the same thing. It's because they are the same thing. It's not super complicated. It's just converting back and forth. That's why we're going to use this, because it's easy to do. Everybody okay with that? Let me show you something that happens to be true here when you convert. Notice that original form, 2 cosine 30 degrees plus I sine 30 degrees. It is set up for you just to multiply as well. If you wanted to, all you really need to do is distribute that 2, and it will get you the same answer. This is 2 times radical 3 over 2 plus I times 2 times a half, because that's what sine of 30 degrees is. It's 1i. It gets you the same answer either way. You could use the formulas or just distribute and you get the same thing. Questions? Let's look at the bottom one. So let's look at example 6. This time we're going from rectangular complex to polar complex. So it's starting off in rectangular complex. So right now it's in the form x plus iy, or yi, however you want to say it. It's the same thing. We are going to get in the form at the end of z equals cosine plus I sine, where all you need to fill in is your radius and your angles. And those angles are always going to be the same. Take a second and do that for me, please. It up. I'm doing Pythagorean Theorem. They gave me x and y. I want r and theta. So to get r, I'm doing Pythagorean Theorem. Negative 5 squared is 25. 5 squared is 25. I get 50. But I want to square root that thing. When you simplify, and you need to simplify, what number is going to be in the front of your radical when you simplify square root of 50? Yeah, good. Yeah, way to show me. 5, I didn't say that. Yes, that's my fault. 50, we break it down into 5 and 10. 10 would break down to 5 and 2. You got a pair of 5s. It is 5 square root of 2. Second one, it's tangent of theta. I want theta, so I'm doing y over x. The 5s simplify to tangent of theta equals negative 1. I don't care if you do it in radians or degrees on this one because I wasn't specific. I'm going to do it in radians because that's what we do all our answers in for the most part. Theta equals 3 pi over 4 and 5 pi over 4, 7 pi over 4. Show me with your fingers, which one do you want here? Do you want the 3 or the 7? Audrey, why do you want the 3? Good. The original thing had a negative x value, so if it had a negative x and a positive y, that would have put her in the second quadrant, and so she wants the angle that will put me in the second quadrant, which is 3 pi over 4. Questions on how we did that? That is the hardest thing we're doing today. So if you can do that, everything else is significantly easier than that. So again, now we are taking this knowledge of complex numbers and we're going to apply it to make these next problems super easy. To multiply complex numbers. Again, if they were rectangular complex, it would be a problem like this. Let's do minus 3i. What would you have to do to multiply those two things together? FOIL, you would do that times that times that. You would multiply it out. Remember, I squared gets you negative 1, and you kind of multiply. It's a lot of fun. All right? That's not crazy tough. This is super easy. All right? This is a little formula that you might need to remember, but it's pretty straightforward. To multiply two imaginary numbers together in polar form, all you need to do is take the two radiuses and multiply them together. And take the two angles and add them together. That's it. So if I want to find z times w in this first problem, if I want to know what zw is, all I'm going to do is take the two radiuses, the two numbers in front, and I'm going to multiply them together. I'm multiplying, so I multiply them. It's 9 square root of 2. I can't combine them, so that's my answer. And then I'm going to take the two angles and fill into this form. I'm going to take these two angles and I'm going to add them together. So 60 plus 185, 245. I am now done. That's it. That's all you have to do. It's way easier to manipulate complex polars than rectangular complex numbers. We could convert this back. If we wanted to, we could put this back into rectangular form. That's not what it's asking. We're just multiplying the numbers together. If your angle that you get is not between 0 and 360 degrees, change it so that it's between 0 and 360 degrees. You can do that pretty easily. Try the next one. We're taking z times w, so we are multiplying the radiuses together. Mara, what'd you get for your new radius?
6 radical 2.
Yep, 6 radical 2. She took 3 radical 2 times 2. Wonderful. Then we are continuing here, and we are dealing with the angles. Cole, what am I going to do with my two angles here? Add them together. So you took 240 plus 300, which would get you 540. We're not going to write 540 in, though, because it's too large. We want to get it in between a regular unit circle, 0 to 360. So what would you have to do with that? So what angle did you end up with? 180. 180. Done. If you notice something about this, this number is no longer imaginary anymore. The reason it's not imaginary, what is sine of 180 degrees? 0. And so this ordered pair really matches up with 6 radical 2, comma 0. Because, well, negative 6 radical 2, because cosine of 180 is negative 1. This is this in rectangular form. We just made a conversion. Questions with multiplying? If you thought multiplying was easy, dividing is easier, or the same level of easiness, I would say. Again, think about rectangular numbers. 3 plus 2i, 5 minus 4i. If I wanted to divide those two, we would have to clear the fraction. you would have to get rid of the 5 minus 4i, so you'd have to multiply by the conjugate on top and bottom. You would have to do a whole lot of foiling. It would be lots of fun. You would not like me as much. All right. Instead, we are dividing with polar complex. To divide polar complex, this time, you divide the two radiuses and you subtract the two angles. That's it. Do the next two. Divide them and subtract. See what you get. Z1 divided by Z2. If I were setting that up, Amanda, what'd you do to take Z1 divided by Z2? Yep, we take the two radiuses. She's dividing them, so your radius is now going to be 4. 8 divided by 2 gets her 4. And you've got 210 and 90. Obviously, the top one is the one we're going to start with, but for subtracting. So it's 210 minus 90, which got me 120. Done. That's my answer. If I'm doing the second one, Z divided by W. Grant, what'd you do to get Z divided by W on 6? Square root of 3 by 7, yeah. We're not going to overly stress about radicals here. We could get rid of them pretty quickly with a radical in our denominator. In this case, it doesn't have one. And then what'd you do with the two angles? Yeah, it's 90 minus 150. So 90 minus 150 would get me negative 60. I don't like negative 60. We're going to put it back in our unit circle. So what angle did you end up with? 300. That's it. That's all you got to do. Questions on that one? Last one. We are taking a complex number. We're raising it to a power. So again, if I gave you 3 plus 2i and I told you to raise it to the 6th power, you would not talk to me anymore. It's too big. You would have to FOIL that out 6 times. It would not be a fun problem. But we can do it really easy with polar complex. This thing that we're about to use is called Moraes Theorem. It's a fancy way of saying this is what you do. Okay? This is the guy that figured this out. All we're going to do, it's very similar to the other stuff. We are going to take your radius and you are going to raise it to whatever power it says. You're going to raise the radius to the power, just like when we divided the radiuses or multiply the radiuses. And then you're going to take your angle and multiply by your exponent. So for this first one, you would take Z equals 4 and you would square it. It gets you 16. And then for my angles, what am I going to do with this 30? Multiply by 2. 30 times 2 gets me 60. Gets me 60. I'm done. Make sense on that? Might need a calculator for a couple of these. Try the next two. Example 8, we are taking that number and raising it to the 5th power. So Alyssa, what'd you do with that? 7,776. Wonderful. Yep. So she took that 60 times 5, and that gave her 300 degrees. 300 degrees. Done. So much easier. Again, it's the reason why we do polar complex, because it allows us to do these calculations really simply. What about this last one? Carrington, what'd you do with your radius here? Yep, 1/2 to the 3rd power, so that's going to get him 1/8. He could cube the 1 and cube the 2. That would get him 1/8. And then with your angle, what'd you get? Good, because you take 225 times 3, which gets you 675. That was too big, so he subtracted out of 360. It got him 315. Good, that's it. Questions with something we learned today?